All right. Perpendicular lines can have different, they do have different slopes. Specifically, their slopes are opposite reciprocals. Right. X-intercepts, yes. Y-intercepts, they can have different Y-intercepts. They can't have Esterbrook's. That makes no sense. Seriously, who would put that on a worksheet? Okay, parallel lines, can they have the same slopes? Or have different, can they have different slopes? No. They have the same slope, right? Can they have different X-intercepts? Y-intercepts? Esterbrook's? No. Right, parallel lines being boom, boom, right? Those have both different Y-intercepts and X-intercepts, but the same slope. They don't have any Esterbrook's. Perpendicular lines, that was a terrible drawing. These guys have different X-intercepts, you can see, and different Y-intercepts, these two. Okay. They don't have any Esterbrook's. Right, equation of the line perpendicular to the line with that. Perpendicular slopes are opposite reciprocal, so the slope of this line is 3, the perpendicular slope is -1/3. Okay, then we can put it in slope-intercept form first if we want, or we can put it in point-slope form. Slope-intercept form is this guy. If we put the point and the slope in there, -1/3 as their slope. Solve for b. That's 1 plus b minus 1, so b is 5. b is 5, slope is -1/3. So we put it back into y equals mx plus b. Y being, y equals, we had our slope -1/3 x and then plus 5. If you do it the other way, y minus 6 equals -1/3 x plus 3, distribute, and then it's a -1. Add 6 to both sides. It's 5. -1 plus 6 is 5. Okay. All right. Rotating this. I'm going to try to do this straight on the tablet, just with the compass. So just bear with me. When I do it, the first thing we do is draw a line between P and A. Okay. Then we want to rotate A counterclockwise. So counterclockwise is that way. And I would recommend drawing the arrow so you know what side to put your protractor on. If you drew the arrow up, your protractor goes up like this. If you drew the arrow down, it would go down like this. Okay. You always put the business area, the little spot there, the vertex spot, the hole, put that on P because we're rotating it around P. So the angle has to be at P for us to rotate it. So put it on, line it up with that line. 130 degrees is going to be over here, not here. This was bad because that's only, that's 60 degrees. That's 50 degrees. So we draw this. We measure between A and P. We measure this distance, and we mark it over here. For me, I think it's like 1.5 just for centimeters. Okay, so that's our new A prime. Do the same with B. I like to erase this stuff. Do the same with B. Okay, draw that down there. B counterclockwise would be that way, so guess where the protractor goes? The hole on the protractor, the vertex spot goes at P, and we put it right there. Okay, on that side of the line where the arrow is. $130. It's up there. Okay, and then we measure that distance, measure this distance, and remove that over here. It's going to be 3.2 centimeters. 3.2 centimeters for me. B prime. We do the same for C. counterclockwise that way. Protractor goes up again for the arrow. The hole goes right where P goes, 130 degrees. Draw this line, and then measure the distance between P and C. For me, that's 7.2. So it's up here. C prime's up there. Off the charts. Then I connect my dots at the end. Ah. Oh, well. You guys get the point, right? Okay, yesterday, the activity that we did in class was geared to get you to take the 6 sets of things that we have to show to be congruent in order to show that 2 triangles are congruent, was to whittle those 6 things down to just another set of 3. Okay. The 3 that we whittled it down to yesterday was ASA and AAS. Okay, angle side angle being ASA and AAS being angle side. Okay? That is added to the 2 that we've already learned. SSS and side angle side. Okay? Those are the 4 different methods that we've done, that we've walked through to show triangle congruence. Okay? We did SAS, SAS. We did side, side, side. We did emphasis on the double A. Emphasis on the double A. And then we did SA. Okay? 4 different ways that we taught it, that we went through. Okay? The ones that we did not say gave us triangle congruence was, some of you guys came up to me and drew a triangle with just 3 sets of angles congruent. Okay? That's that's bad. It's like I'm getting hurt, right? Bad. Okay? The other one is side, side angle. That's backwards. That's bad, backwards. Okay? These 2 are bad. Okay, these are bad. These don't show that triangles are congruent. Like you just got hurt bad. Opposite of SSA is an appropriate word to write on the screen right now. Okay? Okay, more specific on ASA. ASA means if 2 triangles have 2 corresponding, you know what? It's written right there. I forgot that earlier too. ASA, if 2 angles and the included side of one triangle are congruent to the corresponding angles and included side of the other triangle, the triangles are congruent. The important part about that is the fact that it says the included side. Notice how S is between the 2 A's when it's written. Okay? That means a side congruent. Examples of that? Okay? An example of that would be like this setup right there, where the side is in between those 2 angles. Again, this setup right there, where the side is in between the 2 angles. Okay? Doesn't really matter which direction those are drawn in. You know, it could be like this. If we saw it like that, we still have a side in between. I should put a second tally mark. A side in between 2 angles there. A side marked in between 2 angles. Are you with me on that? That would be ASA. The next one, emphasis on the double A. Example on that one, emphasis on the double A would be boom, boom, and the S not included in between the 2 angles. and the S not included between the two angles. Okay? That would be, we could use those to show that two triangles are congruent, or we could use, say, a setup like that. That works too. Okay? I know my pictures aren't to scale, obviously, so my angles don't match when I marked them as congruent, but that's okay. Okay, as long as they're marked to be congruent. You know, it's the two arcs and the one arc, then the side on the outside of those two angles. Okay, it's non-included on ASA or on AAS, on it's the non-included side that we're talking about. Notice how S is written on the outside of the two angles. That means when you see it in the picture, the side has to be on the outside of those two angles. Now, let's take a look at these things and let's determine whether these triangles are congruent or not, based off of the information we get. Remember, we have 4 that work. There are 2 that are bad. So, SAS, SA, emphasis on the double A. The ones that don't work are and the backwards bad language. Those are bad. Okay? So let's see if any of those apply to question 1 to see whether we can state that these two triangles are congruent. And if we can, we're going to write our congruent statement for those triangles. Okay? We're going to say, are they congruent? Why are they congruent? Then we're going to write the congruent statement if they are. All right? So are they congruent is my question to you guys. We have a situation right here where we had mentioned that the angles are the same. So we have 1A in it. We also have a situation here where we have an S the same. Do we have anything else that are congruent? Anything else that pairs up? You know, I'll write these in green. Is there anything else that pairs up? That's the question. Okay, if you look at number 1, you notice just as we just discussed in class that those two angles are congruent. I got to mark them with 2 arcs because these angles were marked with 1. Those 2 angles are congruent to each other, and the reason for that is because those are vertical angles from each other, and vertical angles are congruent. Okay, before we officially have to say, before you know that they're actually congruent, you have to get to the A. In this case, this is going to be a AAS because the S is on the outside. Okay, around the triangle. It's a A. These are congruent by AAS, and the step before we got there, we were able to say that that those were vertical angles, so they were congruent. Okay, and then we write the congruent statement, matching them up. So I'm going to erase my letters on it so I can see the marks a little better. Because I need to. So if I say angle, I in the first one, and then I say which angle does that match to in the other triangle? I. Right? And then I say G in the triangle on the left, so which angle matches up with G on the right? Be J, right? And then on the left, the third one, H, and then K. That's all. That is all that's needed. All of that is needed in order to answer question 1, based off of the directions. Okay? Let's go ahead and do question 2. Are they congruent? And if they are, tell me why, and tell me the congruent statement. So, are they congruent? Well, let's look through it. We got to approach this. Oh, these angles are congruent. Those 2. That's a set. Do we have another set? Oh, there's I wanted that to be green. That's another set right there, right? And then we have a set of sides, right? That side, those sides are between those 2 angles, aren't they? Are they included in between the 2 angles? Yeah, that's an ASA. They're congruent by ASA. And what's the statement that matches the 2 triangles up? Well, we go and we look up the markings. So we're going to go 2 arcs, C and R. 1 arc, B to P, and then no arcs, and then no arcs. Okay. Again, the ordering of those is if you did ABC, if you wrote triangle ABC, then you needed to write triangle QPR. Does that make sense? So the ones in the first spot need to match exactly to what's in there, or the ones in the second spot need to correspond. What I mean by that is saying C and R need to match, B and P need to match, and A and Q need to match for it to be right. Okay? Keep going. Are they congruent? Well, there's an A, and an A. There's an S and an S. Okay, one tally, one tally. And then an S and an S. That is a bad word. So that's no. That's a bad word. Okay. Four. Are they congruent? Well, A, right? Those match. S, A. The S is in between ASA and the congruent statement. The right angle from the top one, the right angle from the bottom one, the angle with 1 arc, C, angle with 1 arc, C, and the other angle. Okay? 5, congruent. We can mark these angles congruent, can't we? Vertical angles. That's ASA and the congruent statement. So I matched with I, H matches with K, and L matches with J, based on how the angles were marked. Okay, and I'm not going to write the congruent statement. This one's emphasis on the double A. I suppose I could write the congruent statement. It won't take long. Okay, so we want to name the additional congruence parts to make sure that that postulate or theorem holds true for these two specific triangles. We have an A and an A and an S and an S. We need another A. Okay, so we need an AAS. We need another A that does not make the side in between them. Okay, we need an A that is on the outside of the set. So we actually need this guy congruent to that guy. We need to mark it with 2 arcs. Okay, that way the side is not included in the 2 angles that are currently marked. Okay, so that's part of it. That's identifying what it is, but that's not naming it. Naming it would be angle R congruent to angle C. No, duh. I can't read. Angle D. Okay, the one that does not work, that definitely does not work, is saying that M congruent to C. That is 100% not going to work, because that would be an ASA where the side is in between the 2 A's. Okay, that would not work. To get an ASA situation, we need the S to be in between the 2 angles. So if I drew this angle up in here, S is not between the 2 angles that we would draw. So I need to add B to it. And then I look over here, I need 2 arcs on the angle so that the side is in between. It would be S. And we can continue. AAS, AA. Okay, we need the S on the outside of those 2 angles. So we could do these two, 2, 1 angle, 2, 1 side, 2, 1 then side. Okay, so we could do OM congruent to AB. Okay. Or there's a second version. We could do the second version, ON congruent to AC, because then it's 2 or 1, 2 side. Okay. And then ASA here, the side would have to be here. There's no switcheroo on that. Okay, we're just going to label which theorems used for these problems real fast for those of you that looked at it. I'm not going to write a congruent statement. But for 9, this is a side-side-side scenario, right? For 10, ASA, yeah, ASA. For 11, SSA or ASS, that's bad. No. Okay. And then this would be AAS, AAS. Emphasis on the double A. Okay. Put your stuff away, please. I know we're shutting down 5 minutes early. I'm going to show you guys something that we're going to get into next unit. So on Monday, okay? And I want you guys just to listen, and I just want your brains for the next 5 minutes, okay? That's it. So put everything away. Make sure your phones are away. Everything. Return the protractors right now, and then we'll go from there. I'm going to set up a quick proof for this, and I'm going to give you the information given that GH congruent to KJ. Okay, I'm going to give you that information. I'm also going to give you that angle G congruent to angle J. Okay, that's the information that's going to be given to you. Okay, and I'm going to ask you to prove that triangle GIH congruent to triangle, we said G first, JIK. Okay, that's what we're going to prove. That's the result. You guys already did that, and you said that we're congruent by, what do we say, AAS, right? We already said that. We went through that process. We're just going to tidy it up a little bit. So the first reason I'm going to give, first step, is going to be, I'm just going to say, oh, it's the given information. Look at it. You can see it, right? One given. Okay? And because we're proving triangle congruence, the given information gave us this side and that angle, correct? Gave us an A, and it gave us an S. So I'm going to just write that to the side just to say, oh, we have 2 out of the 3 that we need. We either need another A or another S. That is not spelling a nasty word. Okay? Second statement, you guys looked at it and you said, oh, yeah, angle GIH is congruent to angle KIJ, right? We said that was true. We just didn't articulate it super well, but we said that those were congruent, right? And we said that's because vertical angles are congruent, right? That's what we said. We already had that discussion. So that gave us another A. It's not ASA because it kind of broke in there, right? The order was a little bit different. But now we have a set of 3, 2 angles and a side. Okay, so we're in good shape. We can actually state that the triangles are congruent now. We can make the final statement. Okay, you with me? And why were we able to make that statement? Well, because it was AAS, right? AAS specifically we got from steps 1 and 2. Okay? All that was taking our conversation that we had on this problem, we just wrote down our conversation in a very kind of specific format. Your homework, I'll project it if you want to see it. If not, you can just find it online.
All interested in table tennis, aka ping pong, tomorrow there will be a meeting outside of the contest gym for all those that are interested at 3:15.
Push. Did the proof seem scary? A little bit. Did it? What? See ya. That seems scary to do. That seems scary, Baylor.